How to connect the system to edge router. Um, so you have all the access net at home. Um, till some years ago, there should be all wired connections, right? But now wireless is much more popular. And that way, we do not have uh, to break the wall at all. Everything is wired, wireless. Even motion detectors, right? At home surveillance systems are all connected wirelessly these days. And also, um, um, yeah, surveillance cameras from outsiders, I mean, exterior surveillance cameras can also send the images wirelessly to your receiver. And wireless cameras can run from solar power systems as well, right? So everything is not necessarily physically connected, but anyway, they are very successfully connected with no cables. Residential and institutional, they're all possible. Mobile access networks these days is really popular. But keep in mind the bandwidth. Everybody is talking about bandwidth or uh, data speed. Bandwidth actually is some width of the frequency band. That's related with the speed. So exchangeably mixed used, but in accurate term, bandwidth is frequency bandwidth, and data speed is bit per second, bps. It's not byte per second, right? Bit per second. You may figure that out why it is bit, right? If you learn um, some modulation, data and signal modulation, then you fully understand why we are talking about bit, right? Bit is it's like a pulse signals. If it is digital signals, then there is a pulse. Per pulse, no, per data, we can consider the number of pulses to modulate it together with per data. Data means one bit. Per bit, we need to figure out how many pulses can be modulated. Okay, sometimes one bit of data and two pulses together mingled. We call that encoded, right? So encoding data can be okay. So that is a bit per second. And then the connection, sometimes dedicated, sometimes shared, many times shared. So we all are using shared connections. At Mercy, we have also wireless routers, broadband wireless router uh, provided to our community. But that is shared, which means there's a limited channels open. If you have so many connections and channels fully booked, then at some point in time, your device cannot find the available channel. Then that short period of time, you don't have a connection. But channels can be reopened and available for you to use all the time, automatically. Okay. Um, so access net. At home, we all use digital subscriber line, DSL. This may be an old type, but still many home has this configuration. Through the telephone line, it's not really, not necessarily telephone line, some line, okay, fiber optics, usually owned by communication company like Verizon, AT&T. They own this, and you subscribe it. A cable vision also. But usually there is a setup splitter, split voice, telephone line, and the modem. From modem, well, TSL modem, and then from the modem there's a TV set connection, right? TV set, and then from this modem you will have wireless router. Right, wireless router. So your PC is connected to that wireless router usually. This is TV sets, very old type TV sets. It's the best way that I can draw. Many times the modem and this wireless router may be combined together, but that's a separate device usually. So you may sit on your laptop or computer. This may be connected wirelessly, usually. This is wired. This is wired to your TV. These days we have also digital TV, so this TV can also receive the signal, wireless signal from the router. And then telephone line, usually wired connection to the telephone line. So all together, this guy and then TV and telephone voice line all together can be modulated here and sent out. When such a signal comes, then when it arrives here, it should split the voice from others. Okay. So there is a multiplexer. So what we do is use existing telephone line to central office DSLM and data over DSL, voice over DSL. So speed is 2.5 megabps upstream, downstream 24 megabps, but a lot higher than this. These days, maybe 50 megabps downstream and maybe 5 megabps upstream or more. So you can check your speed. There is a test website, dslspeed.org or dslreports.com if you like. Let's try if it works in our case. What you need to do, you need to go to websites. Now very nicely connected, my website. And then you can connect dslspeed.org, DSL. speed test. Run. Wow, this is real time, right? New York, idle latency is 9 millisecond. Virginia 12 millisecond. Georgia 21. Quebec, Canada 23. So New York is fast. Cancel Robert gigabit fiber. New York again the best. Right, if you see this. Let me see the other. What is this? It's Android market. DSL speed.org. DSL dash speed. Maybe not available. Oops, I lost. Test was cancelled. Oh, if I. All right. So test is possible, as we just looked at. Okay. If it is cable network, then similar to the configuration here at home. So through the cable lines, there is a splitter between the TV and the modem. So cable has open channels. So some channels for video, some channels for data, and channels for control. So all the video should go through the video channel. All data should go through the data channel, which is called the frequency division multiplexing. Actually, let's say this is the frequency band allowed for the data communication, civil data communication. Actually, frequencies range starts from 0 to very high, 10 to the power 20. Only the frequency that we use, human, is 2.4 gigahertz, which is 2.4 billion frequencies. Frequency means the number of the signal fluctuation, right? Wave cycles, number of cycles per second. Our electric light bulb is 60 hertz per second. You can see me, right? Your visual light is a lot higher frequency than your hearable acoustic signals. Acoustic signals frequency is usually 20 hertz to 20 kilohertz. That is a frequency bandwidth that we can hear human. Doggies can hear a little longer, higher frequency. Some birds, like chicken, hens, can hear shorter, narrower frequency bandwidth than human. Which means if you shout to chicken, hens, they don't hear you. So sometimes you hit him. But their frequency band, hearable frequency band, is that narrow. Bat, Batman's frequency bandwidth is a lot wider, so they can hear also from the cave. Inside the cave, they can hear what's going on outside. Fishes, very narrow. They don't hear much. Anybody talk to fishes? Hey, jump out! I have some cookies for you. Don't stay under the water. Yeah. Lights is a lot wider. In between there is a 2.4 gigahertz, which is 2.4 billion cycles of signals. That is our smartphone, our cell phones uses. Not all cell phones uses 2.4 gigahertz. Old-fashioned cordless phones, the fastest one is 900 megahertz. Cordless phones, right? It was very expensive. I think $200 when it came out first, about 15 years ago, right? 900 megahertz phones. I know some of you still remember, right? And also Europeans' cell phone, GSM, they use 1900 megahertz or 1800 megahertz band. Our cell phone here in America, 2400 megahertz. We call that 2.4 gigahertz, right? 2400 megahertz means 2.4 gigahertz. Frequency, we're talking about the frequency. That is 802.ANC, but there's another bandwidth, right? If you have, yeah, ANC is different standard than B, G, and some other the regulations, right? So IEEE regulations. We're not just talking about wireless. So frequency. Microwave that you usually use, microwave oven, that's a 2.4 gigahertz frequency. So microwave generates the frequency, the same frequency that our smartphone uses, but different applications, right? So microwave oven using the frequencies and heating some. Your phone carries the data over that waves, different applications. But anyway, yeah, each frequency band can be not all entire bandwidth should be used by one customer. Can be divided by multiple bands. And even that multiple bands, we need to divide it sub carriers. We call that channels. For each channel, we send the data. Also by time sharing. So actually, it is a two-dimensional. Let's say this is a time, and this is a frequency. This is a frequency only here, this picture, right? So you need to rotate to 90 degrees. So each frequency can be divided into, this is the frequency band allocated for us to use. There are wider range available, but only limited range is permitted for us to use by FCC, Federal Communication Committees, right? So bandwidth that we use is in the range permitted for science, medical, and industries. That's called SMI frequency band. So SMI frequency band permitted for science, medicine, and industries. There are some band, for example, 900 megahertz and 1900 megahertz, 2400 megahertz. Some range, some bandwidth around that band that I just mentioned. But again, this is wide. Although we are talking about these are all 2.4 gigahertz. We subdivided it smaller, so we call that channel. And also we share that line over the course of time. At some points you can use, say John used this, and Eric used this, and Chris used this. And Chris signals a lot longer than the other guys. Chris uses at this time the channel number something here, and another time still used by Chris, and another time here, and another time here, right? And Eric again reassociate this and start another communication. So two-dimensional domain of frequency and time can be shared and split in this way. Okay, so with the limited resources, the communication can support more requests. That is called frequency division. So we want to divide the frequencies, and also time division in another terminologies, time division. And then finally we need to multiplex. We divide so that user can use it, and also we need to multiplex it. All this together go through one line, for example, if it is Ethernet. All such things should be sent out together from your smartphone, for example. From your smartphone, you have a voice, you have data, you have SMS, messages, texting. Many times it should go together. So you need to multiplex it, right? So all terminologies, these keywords are based upon that scenario. So physical K connections, we use fiber, optical fiber, or hybrid fiber, which is fast. 30 megabps downstream transmission, so data rate, and 2 megabps upstream, which is a lot faster than this DSL. upstream is usually, the other one is 1.5, right? Or 2.5. Upstream is usually takes time. Your Wi-Fi or Ethernet communication, with so-called internet, upstream and downstream uses the same line, but wireless, for example, smartphone cannot share the frequencies. There's a collision, right? Data, same frequency band, data travels in this way, and then another data travels in this way. Then there's a collision, right? So actually, what they did is they split, and partial frequency is only for upstream. We call that uplink, and the other frequency for downlink. So always your smartphone has dedicated the frequency bandwidth for uplink and downlink. So freely they can upload and download, which is not the same as your Ethernet communication. Ethernet communications, uplink and downlink, so two different speed, right? There's some controlling mechanism there. But smartphone wireless networks usually they have different frequency band, so still download is faster. Why is download is still fast? Upload then it should connect to the server, and server needs to take care of so many requests at the same time. So sometimes your upload may go faster, but usually it is not. But download, only the issue about your device. If you have enough memory, then it can come in quick, right? And the communication is done. Edmund?
I just have a question. Is it possible like download from the 5.0 gigahertz and then upload to a 2.5, for example, from the phones?
No.
So can it be connected?
No, they use one regulation. For example, 802.11a or C or AC together, then there is a 5.0 gigahertz and use. But the other way, usually 11G, 11N. What is the current? I think mine is 11 something, right? So 2.4 giga.
So there's no chance that we can like, can it be that we can?
It's not selected by you. It is the carrier's issue. For example, Verizon supports 802.A and C, and your device also available. Then communicate through that band.
I'm talking about the wireless.
Yeah, wireless. That's what I'm talking about.
But you can choose which kind of bandwidth you want to connect. Or piece. You can
It
select
depends on the service company, communication company. Verizon supports, then and your phone is available, then your phone can react. But if they don't, it's all mutual, right? Okay. So we have a DSL and router. At router, usually wireless, right? Oh, well, there's another wireless here. So this is typical router, and this is wireless. In this typical router, you can set up firewall and also uh, network address translator, right? Network address translator, which means you have a fixed static IP address here. It's a static IP. This static IP registered through the data control center. So data control center understand when the data with the destination to this IP comes, then how it is sent out. So it finally comes into my port. So that is a static IP. Once it comes into my static IP, then I might have multiple systems in my territory. Multiple means if I am in a company, for example, Mercy College, then we have thousands terminals waiting inside, but we do not have thousand static IP available. We have only limited IPs. So from that limited IPs, how can I receive data from somewhere outside here, which this guy does not know me at all in terms of IP address, because my IP address is not really associated with the static IP at all. So what it does is here is that in this net address translator, this is a local and dynamic IP, internally identified. Any IP internal within this territory, they are unique. So my smartphone has my own dynamic IP, which is unique within this domain, and this guy also dynamic. When it comes to here, then this guy, this NAT, has a table. So in certain data, if it comes in, then use this static data. And through this static data, it can go out. When some data comes in, this table understands which terminal, which dynamic IP device should receive, so it can send in the data. So that is dynamically, automatically handled by this static IP. So when you subscribe Verizon, for example, or Cablevision, then Verizon Cablevision has static IP, and you are one of this dynamic IP. Then Verizon understands where you are and send the signal to you. Okay. If you want to have static IP, then you need to buy from Verizon. So Verizon should then connect and set up static IP to you. Once you have that static IP, then you can have your own subdomain. You need to set up the way Verizon set up by itself. So you have also here your own router, and then you can serve multiple systems within your organization. Some wired, some wirelessly. Okay. It's all hierarchically organized. Enterprise access network, called that Ethernet. So we have an Ethernet switch, some institutional link, like Morse College. We have an institutional router. So within this domain, we have Ethernet switch, and then some servers available, some terminals available. So typical used in companies, universities, 100 megabps, 1 gig, 10 gig transmission rate. So if you want to read some regulations, then you can find it from IEEE 802.org/3. So 802.3, this number 3 is for Ethernet. If you have 802, IEEE 802.org/11, then that is wireless. Okay, 802.11. 802.3, then that is Ethernet communication. And 802.15, 16, and more. So all regulations available. So Ethernet specification version 1 defined in 1980. So network has architecture, OSI standard architecture. We call that 7-layer. But a little bit modified depending upon the application. If it is wireless, then some modifications. But this is a basic standard. The lowest level, we have a physical line. We call that physical layer. And above, data link layer. And more, right? Transmission layer, and some other, all the way up to the application layer. In this case, simply we call that client layer. It's all depending upon the client. So in the physical layer, what this specification regulated is some algorithm of encoding and decoding, and some transmission protocols. So those are all described in this for this physical layer. Data link layer, so encryption and link management, that can be described here, and more. Okay, so these are all, let's say, from here there, can be implemented in one electronic device, and this can be implemented in another electronic device and another electronic device. So we put them in one equipment. We call that network equipments. So if you purchase the network equipments and install, then this network equipments can handle some techniques defined by or defined for Ethernet. So it can encapsulate or link management, or encoding and decoding, and transmission and receiving. All such things can be handled by this device. Okay, so this device now linked to the cable. Okay, it can be coaxial cable or fiber cable. So wireless access is another. It's very popular these days. So we have wireless LAN, 802.11b and G, so-called Wi-Fi. As Edmund said, there is ANC, which is the frequency band is doubled. wide area wireless network. That is also possible. And for the cell phone, it's a little bit mixed. Wi-Fi is for uh, it's not really cellular signals, right? But 3G and 4G, that is a cellular signals. And 2G also. It starts from 1G. Right, 1G, 2G, and then 2.4, 2.5G also. Right, implementation of 4G can be LTE. So LTE is an implementation of 4G. There may be another implementation to come. You're right, it's not fully implemented. A lot of techniques and regulations are defined. Therefore, this is typical example. While we have 2G, and there is a general packet GPS something, general packet switching network. That techniques came up. That is solely for 3G, but while we have 2G, if we adopt that technique, we call that 2.5G cellular phones. But anyway, we are here, LTE or somewhere there. And anyway, that is 4G. Already many people already started talking about 5G, right? I don't know. Maybe some of the XLD, XLTE, extended maybe. little bit of more implementation than LTE, I guess. So when we are talking about wireless communication, there are actually uh, two different techniques are actively evolved. At one, there is a cellular, at another, Wi-Fi. Okay, Wi-Fi, there is 802.11 communities here, and they're always in this limited distance, within distance, 100 feet. But cellular, it covers more. Cellular needs its own access points. Cellular tower, cell tower, it covers 110 kilometer, which means about 7 miles, 6 miles. It depends. Okay. So host means your client, your laptop, sends packets of data to a router and all the way to the server. So we call that packets. So if we have data and message to send, then that message or data can be broken into a smaller chunk. We call that packets. So each packet can traverse not in a certain sequence, but the packets are generated as is generated. Some packets can take in one channel and the very next packets maybe take another channel and another routings. So different paths of communications takes place so that it should arrive at the destinations. Transmit the packet into access network at a certain transmission rate. It depends on many factors. Frequency, if it is wireless, um, and all other mixtures like capacity, link bandwidth. So we can expect there may be some transmission delay. Transmission delay can be measured in this way. How many bits, the time needed to transmit L bits packet into link. So L over R is transmission rate. So per transmission rate, the bits to be transmitted. Isn't this available on the internet? Oh, that's okay, yeah. Physical media that can carry the data. There are two types, guided media and unguided media. Guided media, then data can traverse along the media. If there is a wired communication, then data traverse on that connection, physical connection, like a copper, fiber, coaxial cables. If data is always guided, right? Like this communication line. But in wireless, it is not. There is no guided media, but it doesn't mean that there shouldn't be any media. There should be a media so that that media can or should carry the data that you want to send in the air. So wave, some signal needs to be generated from your device. The signal carries the data that you want to send out. Usually the data, signal that can carry your data is radio wave. In the range of frequency 2.4 gigahertz, 900 megahertz, somewhere there. Depends on the device that you are using.
The wireless uses Fitbit or the cellular uses radio wave?
All radio waves. Cellular also radio wave. The other one, Wi-Fi also. Yeah.
Cellular uses radio wave.
Yeah, generally we call that, but it is called the wireless wave. Yeah, we call sometimes we say microwave or radio wave or infrared wave. We can specifically stick to a specific frequency range by picking up the accurate terminologies like radio wave. Radio wave has its own frequency band, microwave its own, and infrared its own, right? But in general, radio wave. but depending upon the device that you are using. Coaxial cables, we all know, right? Bidirectional, of course, it should be. Otherwise, you cannot receive while you are sending out. So transmitting and receiving should be done together. Optical fiber, there's a low error rate. It's more accurate. See here, this is a light optic, right? Light speed operation, which means high speed point-to-point transmission. Can go up to 100 gigabps. Media itself can carry that high speed. Only the issue here is that does it have that enough power? Both wireless and wired communication, energy is needed to push the data out. So Ethernet cable, there is a electric power is running, current is running. Resistance on the right, depending upon the resistance, and also the difference of the resistance. Therefore, your router can recognize if there is any collision, data collision. If there is a collision, then a little higher current, so-called the milliamp. If it is a 12 milliamp, then there is a general data transmission current. But above that, for example, 18 milliamp, then typically there is a data collision. If there is a data collision, then your router would need to react to fix it. Wireless, there's no way that you can fix. The Ethernet, usually they fix it. We call that correction, right? Collision correction. If it is Ethernet, then, for example, you receive email messages. But unknowingly, partial of emails, because you have a long emails, size very high, very big size, then your email needs to be chopped into smaller. We call that packet. Partial packets comes in, partial not yet. But your application program needs to provide you all at once. Yeah, a long time ago, some application program can open only partial emails. So I don't see the rest. But now your application programs make sure that if it is an email, then everything from the beginning to the end, everything comes in, then open for you to read. So you may read all or not. If it is not, then your application program or your network device re-request. Then sender will re-request, resend it. We call that correction, right? If there is anything wrong, then correct it through the Ethernet communication. But that is not the same as, for example, wireless communication. Wireless, your mobile phones is moving. Sometimes cellular tower is moving also. All the cellular towers not necessarily fixed. I think 99% fixed. But there is a mobile cellular tower also. It is always possible. Verizon also provides mobile cell tower. When there is some crowded, massive gatherings, then they send their a mobile tower, like a truck. It happens decades ago also. When we had the September 11th, all cell tower collapsed in the city. At certain time like that, more people wants to access cell tower, right? Everybody wants to say something. But cell tower collapsed. What happened at that time then, Verizon and AT&T sent out hundreds of mobile cell tower trucks. And they stationed all around the cities, and they take care of all such things. So point here is that if we want to fix it, correction, then we need to know which one is the sender, which is the receiver, so that we can say, oh, resend to me. But your cell phone and cell tower both are moving. You lost the connection. So that is not good technique. Correction is not really recommended in the wireless communication. So what they do is, let's avoid the errors. So there is a more handshaking. So no collision occurs. We need to make sure when I talk to you, there is no collision. So we need to make sure your point and my point in between. And therefore, now I'm ready. Are you ready? Send it to me. But Ethernet communication is not like that. We send out. So a lot of network devices, network equipments and handles such things. And if there is an error occurs, then they will request. This is something other than this slide. Okay. Radio link types, Wi-Fi and cellular. Again, it's not specific frequency range for radio. For example, radio FM, AM. We're not talking about that here. When you say radio wave for wireless communication, it's more broad term, which means wireless. Signal up on the air. So it covers the microwave, which is a specific bandwidth. I think we need to take a 10-minute break. 10-minute break. Hold. Okay, let's continue. Chapter 1 gives you a broad idea of networks. Can I? Okay. Therefore, so many subsections. But for your midterm, I need to jump up. I'm going to finish up 1.3 and then jump up to specific one of the network layer, which is here transport layer. The main reason for that is some questions raised from this transport layer. So cover 1.3 and then switch to the chapter 3, which is transport layer. Again, we're not going to cover all the chapters, right? Which is amazingly at Mercy is the 2-semester course. Eventually, we will combine them into one. Therefore, students can learn more advanced courses than stay in the basic levels all the time. Well, particularly, for example, programming, Java, then 2 semesters, and network, 2 semesters, software engineering, 2 semesters. And what else are 2 semesters? There are so many 2-semester courses. Should be in 1 semester. Therefore, by taking 120 credits of undergraduate requirements, you will end up having all those good courses. Usually, one of the good courses is artificial intelligence. That is, I mean, without knowing that, it's very hard to answer all kinds of interview questions. So all the advanced techniques are from the artificial intelligence. Even search techniques, there's advanced search techniques covered in artificial intelligence. Some programming also covered in artificial intelligence. So all anything intelligent. What we want to do here is when you do programming, when you develop some systems, this is a general idea. First effort is to make it executable. Once it is executable, then next thing that you need to do is make it beautiful so that customer can be impressed, right? So there is a graphical user interface. So 2 things can go together. That is the reason that our Python programming, we covered executability, and then visibility, a graphical user interface. Still, there's something missing. What is that? Is we never done anything about intelligent. We didn't make our system intelligent, right? There's no brain in our system. That should be done. There's a 1 separate course, artificial intelligence, 339. I offered many years ago 3 times, and then because of a low enrollment, and it is cancelled. And since then, I do not offer. Anyway, it'll be cancelled. So the artificial intelligence is important, of course. And after that, what? So you make you develop something executable, something beautiful, something intelligent, and then finally, that's the thing that we all are interested in. Therefore, we are here. Should be secured, right? Executable, beautiful, intelligent. But if it is not secured, then you lose all the data. Compromised data that you are dealing with, your program deals with, compromised. You will receive a lot of lawsuits from your customers, right? So 4 factors: executable, beautiful, intelligent, secured. So we do secured, so we have 1 separate program, secured. We have a computer science program, which is make it executable, but not in between those 2, right? Make it beautiful. We do not have enough time. Intelligent, same thing, right? Okay, so back to our chapter. Network core. See here, we have basically three communities. The top, we have all wireless users. And in the middle, we have home users, residential users. Uh, and the bottom, the rest, others. There may be some industries, hospital, government, some other countries also. They are connected through uh, network equipment. And we send the data and receive. So data, usually, that you want to send or you may receive, large, big. Particularly the data recently used are big because it has a multimedia involved. Sometimes you receive movies, right? How many of you frequently watch movies from, yeah, your laptop or your smartphone? Many of you, almost all, yeah? So I want you to think two different issues, which will be covered in the transport layer, chapter 3. Um, when you receive emails, then email should be completely, the email message transmitted completely. If there is any missing, then it should be fix it, right? It should fix it. So there is one type of protocol available. But while you are watching video, you don't really care. We do not care if there is any uh, any one scene is missing. We don't really care. Not only us, our system, our application program, or our network protocols do not care, right? So do we. So another protocol is available. One protocol, very sensitive, should take care of completion and soundness. The other type of protocol usually do not care if something happens. Okay, let it go. Keep going, because we do not care. Network device do not care. There's another protocols available. They all together walk through in this connection. In all cases, the messages are split into a smaller chunks. We call that packets. So packets traversed. So switching mechanism is called packet switching. Packet switching is a host breaks application layer message into packets. Forward packets from one router to next across links on path from source to destination. Each packet transmitted at full link capacity. So let's assume that there is a L bits per packet. So from your application, you generate L bit messages. Internally, it is broken into many smaller size of data. We call that packet. And packet is usually attached to the header at each level. So header grows from the application layer all the way down to physical layer, some layer. Each layer functions different differently. For example, application layer deals with the application only. For example, visualize it. Okay, run the application. If you run database, then database is an application. How the data generated from your database is broken into a smaller packets is done by some other layer. Your application doesn't do that. Your application just generates data. All the different missions can be taken by different layer. So at each layer, there is a at each layer there's a header to attach it to the packets. As data comes from top to the bottom, bottom means the physical layer, header grows. When I done some work, then I attach my header. Why I need to add my layer? Do I need to attach my header into the packet? That is because at the other end, receiver side, there is a corresponding layer as mine, and that layer needs to combine it. If it is broken, then combine them. So we have to replay as it was originally created. So that I need to understand which portion that I need to deal with at my layer. If the other layer, corresponding layer, broken into the packet, then at my receiver layer, I need to combine them by looking at the header information. Okay. So I have a source and destination, and my application generates the messages, and it can be broken into the packets, and packet is sent over the networks. Right now, we do not care about the media, whether it is wired or wireless, but we care the data rate R. Okay. So it takes L over all second to transmit, which means this is the data size. All is the rate. Rate means the amount of data carried per second. But I have X amount of data. Then we can estimate how long does it take, right? So we can estimate these many seconds will take to send out L bit. Okay, so we forward that too. Let's say the data size is 7.5 megabps, and then rate is 1.5 megabps. To send out these all data through this rate, how long does it take? It takes 5 seconds, right? We need to do L over R. Hold on, there's some. Oh, see my bullet. My cursor in real at some distance. When I write here, that comes. Okay. So if I mark here, that marks 5 seconds. Okay. It'll follow 5 seconds. 5. Okay. 5 seconds. How it does? It comes from L over off. Okay. See here in this queue, rather than pen, I'm going to use highlight. This queue, Q is in the router, for example. What is a Q? Q-U-E-U-E. Q is a common name, common terminology, right? Q. You can see the Q in many places, many, daily basis. If you go to bank, then there's a queue, right? So you can, when you enter the bank, there's a one queue, therefore you can stand at the end of that queue, and in the queue, there's a multiple customers. So customer at the front of that queue can be served first. And then customer just comes in for waiting, then customer should be at the end of that queue. So always there is a queue. So queue is the mechanism to serve first come and first basis, right? There's a queue. Networks, queue is implemented throughout all the equipments. First come, first served, in general. But actually there is a priority-based queue also. Priority, so-called priority queue. If there is any priority, then higher priority should be served first. If they are all the same priority, then first come, first served. That's called the priority queue. How to implement it? It's simple. In programming, if you take 311 data structures course, okay? Queuing. So there is a one queue in the router, and router serves multiple terminals. Each terminal sends out messages. So message comes from multiple sources into the only my queue. So it comes, first come the front waiting, right? And it goes. Network line itself, that is also similar to a queue. There's a certain sequence. At the receiver side, destination, there is also queue. At every moment, there is a queue, and according to the queue mechanism, data can be handled. Okay. Queue is nothing but the size of memory, size of capacity. So along this line, there's a queue. Okay. So depending upon speed depends on the energy. If you have high power, high speed Ethernet, then data can be transmitted faster. That is the capacity of the line. And router is a real memory. So memory holds the message, which means there is a limited size of queue. That means if there is an overflow, you send out from your terminal, you send out the message. When it arrives, this router where there is a queue, unless it is inside the queue, it is missing. Because more data comes after me, keep coming in, but there's no way that I can get in, then that is missing, dropping. dropping. At the entry point here, it drops. If there is enough capacity in this line, then you can push out faster. Therefore, more vacancies available. Then we can receive more data from there, right? Same thing at the other side. So if it is dropped, then we need to fix it, right? So fix the mechanism of fixing the data error is different depending upon wired and wireless. As I said, for wired, we need to detect and fix it. Wireless, we need to avoid it. Although we detect it, there's no way that we can fix it if it is wireless, because all the components are moving. Two key network core functions, routing and forwarding. Routing is to make a decision. Okay, when the new data comes in, then plan, because there is a multiple outlets. So which outlet that I plug this data in? If there are multiple, for example, in this example, I have 1, 2, 3 different paths available. So when the data comes in, then I know basically which path is available, first of all. Which path is, if there are more than one available, then we can estimate which path is or would be the fast. So we put that data in that path that it goes through that. At each router here, and this router also needs to do routing. So which path? Once it is decided, then forward it into that path. That is the message here in this slide. Routing to determine source to destination routes. Forwarding, move packets into appropriate router output. So router has two functions. Routing itself, that's a decision making. Forwarding, is a push it to that direction. Packet switching is common these days, but there is a circuit switching also. That is also available. Circuit switching is more common several decades ago when we had old type telephone lines. There's a telephone operator. I'm not sure but when I was young, there's a telephone operators. That is one specialty of positions. So physical lines, they receive the call, and then the requester requests a particular destination, then plug that line into that direction physically. Circuit is connected. Therefore they can talk. Packet switching network is circuit is already established, but it's not one-to-one circuit. A lot of different branches, so decision making is needed. But circuit switching, once it's connected, that is complete one-to-one circuits. Usually dedicated resources, but can be shared also. This is what we looked at: frequency division multiplexing and time division multiplexing. We looked at this, right? You have limited frequencies. This is frequency bandwidth. You break into multiple smaller frequency bandwidth to serve users. Time division multiplexing is to break, it's like time sharing, right? And they combine these two also, FDM and TDM. So it's very straightforward, right? Access ISP, Internet Service Provider, and Internet Service Provider are interconnected. Therefore, you at one end of that entire topology can communicate with the other component, the other opponent at the other side of that topology. So topology can be in this way. They're all connected one-to-one. Then a lot of communications lines needed. Another way is that centralize it, and whatever request go into the global ISP, and global ISP among themselves are connected already, so that some routing mechanism applied, and eventually it can communicate. For example, you are here, go there, and it goes somewhere, and this guy, right? In the previous, if you are here to talk to that guy, then directly. There's difference. Another, if the size grows, therefore you cannot have all at one center, then you might have multiple centers also. And center needs to talk like this. So we call that regional network, and Internet Service provide the group A, B, and C, and interchangeable protocols applied. So we call that content provider network. Or that can be think in this way, so hierarchically, regional ISP, and then tier 1 and above. And entirely, if we see the network connections, it looks like this. So this is end user like us. Then we can, if we want to talk someone else, then go up here, then through that peering networks, which means among the internet service provider needs to talk among themselves first. Therefore, as a customer, me at the sender side can talk to another customer at the receiver side. Okay. This is the end of section 1.3. As I mentioned, we need to do here. So, curriculum committee, I cannot attend to that. Transport layer. Our goal is to understand the principles behind the transport layer. What transport layer could do is multiplexing, demultiplexing, and take care of transport and flow control, congestion control. So Basically, two protocols needs to be understood: UDP and TCP. UDP and TCP. Basic difference between UDP and TCP is UDP connectionless transport, TCP connection-oriented connection. Need to show more. Is it here? Maybe. Yeah, maybe here. Let me. First of all, you need a quorum.
It's okay. I'm not disturbing the class, but
Yeah.
you can
You can count. Yeah.
Thanks.
Okay. Let's. Before we get to that, we need to talk about layers. Okay, because it's a transport layer. Then you need to understand the layer. Okay. This is good analogies. Think about travel planning. Travel. Then usually you purchase the ticket, right, in this order, and then check in the baggages and access to the gates, and on runway take off, and then there's the airplane routing. So you don't care about this. It's a physical routing. And then when you arrive at the destination, this is your departure. This is arrival. So this is depart. It's arrive. At the arrival airport, you land and through the runway and taxiing to the gates and baggage claim. If there is anything to complain it, and you are done in this mission, right? So if you see this, there is a corresponding functions. Network communication is similar to that. So we have internet protocol. Actually, in this way, we looked at this link layer and data physical layer. This is called the data link layer. And network layer, transport layer, and application layer. This is part of the standard here. This is a national organization of international standard organization. 7 layer from physical to the application. Application presentation, session, transport, network, data link layer, and physical layer. So what do they do here? For example, at the source, you want to send the message. Message is generated through the application. If you want to email, then email program, that is an application. If you have internet email, then that is also that. And that message, that packet, each packet travels down along this layer, transport layer, network layer, linked layer, physical layer. When it reaches the physical layer, then finally through the Ethernet, physical communication line, message is traversed. When it arrives, switch at some point. Then switch deals with the physical layer and linked layer only. So it goes into the physical layer, into the linked layer. Then at the linked layer, it should know which router it should access. So when it arrives at router, it goes into the physical layer. But router has a little more functions than switch. So it has data link layer and network layer also goes into the network layer. But as you see here, this is a message. This is a header for network, header for linked. Okay, and this network layer, as it goes down, then linked layer is connected. This is transport, T for transport layer, N for network layer, L for linked layer. As it goes down, and more header is attached to it, so it's more headers attached to it. They're all header. M is only the payload. This is the message that you want to send. So as it leaves the router, therefore arrives at the destination, it goes into the physical layer, and when it go up to the linked layer, then by looking at this link header, this linked layer understands what he needs to do and do that work. And when it arrives to the network layer, then looking at this header, and it understands what it should be done, and step by step all the way up to the application layer. Okay. Chapter 3. What we are going to do is to do the transport layer. That's what we are doing. At the transport layer, oh, this is beautiful. Oh, wait a minute. Let me give you this. Look at this. The message was the transport layer, and therefore transport header for the transport layer attached to the message and traverse one level down to the network layer. So corresponding header attached and linked layer header attached. And when it come into the router, linked layer of a router, then a linked layer header is detached and handled, and network layer header detached and handled. That's it. Okay, so back here. So two protocols available, TCP and at the transport layer services. What we will do is we will look at this, but not necessarily entire or all, a little bit of those. In general, at the transport layer, there's a services and protocols can be explained in this way. You have a community, you have some community here, that's where you are, and then you want to access some of the server at the other end of your network topologies. So you run application, and your application comes into the transport layer. What this transport layer could do, Therefore, the very same transport layer at the destination could do correspondingly. What it does is to provide logical communication between application process running on different hosts, transport protocol run in end system, so it sends sender side and receiver side. At the sender side, it breaks application message into the segment. So first time the message can be broken into the smaller size. That is the transport layer. So in the internet, there are two protocols developed for transport services, TCP and UDP. Transport versus network layer. Network layer is a logical communication between hosts. Transport layer, logical communication between processes. Both are talking about logical communication, but network layer is talk to the host only. Host to host. It describes about host itself. Transport layer is a little detailed. Let's say, we all know the host, two hosts, sender side and receiver side. Now, which processor, which process, which means which application program? Is it email process, or is it printing process, or is it, some process? Process is nothing but a program, specific program. So, there's a difference. In the transport layer protocols, there are two protocols available, TCP and UDP. TCP is reliable and in-order delivery. Meanwhile, UDP is unreliable, unordered delivery. Example for that is TCP is email message, UDP, movie, multimedia. Congestion control, flow control, connection setup needs to be done. TCP needs to be done. UDP, no. We do our best, but it's okay. If there's something wrong, then keep going. Okay. Multiplexing and demultiplexing. So what we will do, we'll take another 10 minutes. I'll go back to Dr. Barnabara's meeting. I should be in the meeting, but I'm excused, but they need a quorum. Otherwise, that meeting will be canceled. So it's appear that and come back. So let's take 10-minute break.